Now that we've gone into depth introducing the papers this week, let me please introduce you to my special guest this week. Spike Psarris is a former atheist who worked as an engineer in the United States military space program. Spike wound up becoming a born-again Christian and a young Earth creationist. He developed and produced the incredible video series What You Aren't Being Told About Astronomy to document what he learned and the scientific reasons he rejected the evolutionary paradigm and embraced the biblical account of creation. He joins me by telephone from his home in Washington State. Welcome to the program, Spike.
Thanks, Ian. Happy to be here.
Okay, so you heard the reports this week, 4 of them, and I'm going to home in on several points to be made with each of the models. Let's start with Monier's study of the zinc isotopes. Now, the Live Science article pointed out the very first thing that came to my mind when I read Monier's article, and that was water. We find water on the moon. That was the whole point of NASA's L-Cross project, where they launched a rocket into the moon to kick up debris and examine the debris for water. And unfortunately, they didn't start an interplanetary war. But this brings up the question, how on Earth could zinc have been evaporated by this alleged interplanetary collision, but water wasn't? I mean, I know this is something you discussed in your past newsletters, but Live Science quoted Monnier as saying, the results show that all this water they found on the face of the moon is secondary water. What's your take on this?
Well, the water found on the face of the moon, the surface water, is beside the point. Several reports have talked about the surface water, but that's sort of a weird combination of a straw man and a red herring. It doesn't matter.
So it's sort of like a red straw man herring.
Or something like that,
Something like that. Okay, I like it. Okay.
Because water on the surface could have been brought to the moon by comets and meteorites after it formed. Now, everybody understands that, so surface water doesn't tell us anything about what was happening on the moon during the time it formed. So the real question is whether or not there's water inside the moon, not on the surface.
Okay.
And if the giant impact model were true, there wouldn't be any water in the moon's interior, because it all would have been vaporized during the collision and the post-impact heating. And indeed, the data did seem to support this for a while. The Apollo astronauts actually brought back several hundred pounds of rocks and soil samples with them. And when the samples were first analyzed back in the 70s, they were found to be fairly dry.
Okay.
So everybody figured that meant that the moon doesn't have significant water. But then in the late 2000s, some other researchers said, well, we have better technology now than we did then, so let's go back and reanalyze those lunar samples to see if we find anything new. And sure enough, they did. And back in 2008, a few years ago now, they published their results. It turns out the lunar samples do have water. The samples have about 10 times as much water as was previously thought. And here's the important part in all this, that the samples are made of volcanic glasses. So that means they came from inside the moon during a volcanic eruption. So this means there's water inside of the moon. And that's where the giant impact model says there can't be any. But there was a problem with that first study. That study was done on basalt, and the basalt would have lost some of its water because of degassing during the eruption. So it was clear that there used to be even more water than they were able to find in the analysis in 2008, but they couldn't tell how much. So they went back again, and this time they looked for melt inclusions in the volcanic glass. Now, a melt inclusion is a little tiny sample of magma that gets trapped inside crystals that form inside the glass before the eruption occurs. So basically this means that whatever's inside of there has been preserved since the eruption. So that allows us to actually get a sample of something from before the eruption occurred. Now, no one had examined these before because it takes a tremendous amount of work to find them. It's like looking for a needle in a haystack. So, of course, they assigned the task to a student.
Woohoo, students!
Yeah. So he had to look through thousands of grains to find enough melt inclusions to work with. But he did find them, and once he found them, they analyzed them, and sure enough, there's water trapped inside the melt inclusions. Okay. In fact, they found there's up to 100 times as much water there as the previous study had found.
Okay, that's a lot.
Yes. So this creates a serious problem for the whole giant impact theory now, because that theory says that all water would have been vaporized during the collision. So that means that the moon can't have any today, at least not on the inside. Again, there may be on the surface, but that's not the point. The point is there shouldn't be any on the inside, and that's where the volcanic glass came from. So now we know that the moon's interior does contain water, and actually it's comparable to the level of water inside the Earth's mantle.
Wow.
And they actually found some other volatile elements inside the samples too, but water is really the biggest deal in all of this.
It certainly would be. I mean, that's the same amount of water in the Earth's mantle. I mean, Earth's mantle has a lot of water in it.
Yes.
And, I mean, we're talking about water boils at 100 degrees Celsius, while zinc boils at, 907 Celsius, which is, a little over 1,600 degrees Fahrenheit for you Americans there. So, I mean, it's really hot. So it seems the evolutionists have to believe that the collision produced temperatures above 1,600 degrees Fahrenheit, which was hot enough to boil away much of the zinc.
But it wasn't hot enough to boil away the water. Exactly.
Exactly.
The whole thing doesn't make sense.
Right. Okay, and none of these papers published about the new discoveries, or sorry, none of the papers published about the new discoveries are talking about this. They're not talking about the water. They'll just say we found new theoretical ways that the moon could have formed in a giant impact without talking about the physical evidence that says it didn't happen.
Right. And the theoretical part of this has a lot of uncertainty anyway. And the media reports aren't talking about that either.
Okay, well, let's talk about that for a moment then.
Okay, well, first of all these models, they're just computer simulations. It's not like a laboratory experiment where you can observe something happening and verify that it's true. And not only that, the simulations don't match a lot of what we do actually see. For example, the new impact simulation, it requires that the Earth used to be a different size than it is today, that it used to spin 10 times or even a little bit more than that, 10 times as fast as it spins today, and that it used to be closer to the sun than it is today. It also requires that the moon used to be very close to the Earth, roughly 1/10 or so of the distance it is today. It requires that the moon used to have a very elliptical orbit shaped like an oval, which it doesn't have today, and the list goes on and on. There's all these things that supposedly used to be different that doesn't match what we actually see. I mean, what is the actual physical evidence? The physical evidence that we have is the Earth and moon that we see today. The rest of the model is just storytelling. There's no physical evidence to support any of that because everything that the model requires is different than what we actually see today.
Right. I follow you.
And whether or not the story is viable, I mean, I have doubts about that anyway, because the story doesn't match some other things that we know about the Earth-Moon system.
Okay, now, like what? Can you give us some examples?
Well, the model is heavily dependent on tidal effects to move the moon away from the Earth after it supposedly formed. It also needs tides to slow down the Earth's spin. Again, as I said, the model says that the Earth used to be spinning 10 times as fast as it is right now. But when you calculate tidal effects, which is what this model is based on, you need to know how much energy is dissipated in the planet that you're dealing with. This is affected by things like the planet structure and things like that. Now, in tidal equations, when you're doing these calculations, all of these factors are combined in something called the quality factor, and it's represented by the letter Q.
Right.
Now, Q represents how much energy is dissipated within the bodies, the planetary bodies, as the tidal effects try to distort them. Now, in the new impact model here, they used a range of values for Q, but it turns out the numbers aren't right. For the Q of the moon, they used several values from 48 to 117. But we know what the real value is for the moon's Q. It's only 27. Now, for the Earth, they used, for a Q number, 48 and 96. And at one point in the paper, they even talked about the Q for the Earth being as high as 10,000. But again, we know what the real value is for the Earth. It's only 12. Now, obviously, those numbers are very different. Now, it makes you wonder what's going on here. Since we've actually measured what these values are, why didn't the researchers use these numbers in their models? Now, wouldn't you expect them to do that? I would.
Yep.
Now, I don't know if they did or didn't, but I'm guessing that they did, and that they found the numbers didn't work. So they had to make up other numbers instead, numbers that don't match the actual measurements that we have today. So I guess, the overall point is, over and over again, we see that the model doesn't match the actual physical evidence that we see today. And this is actually a common problem with these sorts of models in astronomy, because to make the models, evolutionists are speculating that maybe all these values used to be different in the past. But science is based on observations, and the past is unobservable. All we can observe is the present, and in the present, the Earth-Moon system doesn't match the model.
Right. Okay. So now we were talking about tides. They also tell us something about, the tides do, tell us something about whether or not the Earth-Moon system can be billions of years old. Why don't you tell us about that?
Okay. Now, as the moon orbits the Earth, it raises tides in our oceans. The moon's gravity actually pulls ocean water toward itself. So that means the water bulges out toward the moon. Now, it actually turns out there's two bulges. There's one facing the moon, and then there's another one on the opposite hemisphere of the Earth, which is the result of the water along the sides getting pulled toward the main tidal bulge, if that makes sense.
Right.
So, now, on Earth, we experience the tides as the ocean rising and falling, but that's not really what's happening. What's happening is that the Earth rotates underneath the tidal bulges, and as you stand on one spot of the Earth, your location rotates into a bulge and then back out of it.
Okay. Right.
The rotation of the Earth isn't shown on this video here, so the viewers will have to imagine how that works, but hopefully that's clear. Now, as the Earth spins underneath the tidal bulges, it actually drags the bulges forward slightly, because there's a little bit of friction there between the ocean floor and the water. So the bulge that faces the moon doesn't line up with the moon exactly. It's actually offset by a little bit. Now, we're talking about a large mass of ocean water here. That exerts a gravitational pull of its own that's slightly offset from the Earth's gravitational pull. So that pulls the moon slightly sideways, which accelerates the moon in its orbit. And the effect of that is that when you accelerate something in an orbit, it moves further away. So this means the moon is actually moving away from the Earth by a small distance each year.
Right.
Now, we know this is happening, and we know how much. We've actually been measuring this effect very precisely with lasers for a couple decades now.
Mm-hmm.
So, if you think about this, if the moon moves farther away each year, that means it used to be closer in the past. So if you do the math, it turns out that the moon would have been touching the Earth only 1.6 billion years ago. Now, I say only. That's a long time.
Yes.
I'm not saying that the Earth-Moon system is 1.6 billion years old. That's the maximum age for the system. It's not the minimum age. Now, I've come to believe that the Earth-Moon system is less than 10,000 years old, and what we see is quite consistent with that. But it's very inconsistent with the long-age view, which needs the Earth-Moon system to be 4 billion years old. 2.5 billion years older than it can be, according to what we see going on today. Now, again, the long-agers, those who accept the long age, have to make excuses here. They make up stories about how everything used to be different, and the recession rate used to be lower in the past, and so it's possible for the system to be 4 billion years old after all. Well, it turns out, if you really dig into the stories all have serious problems explaining that away, and I don't want to bore your viewers with details about that. But even if that weren't true, science is supposed to be based on observations. Right. And these stories aren't based on observations, they're just stories.
Stories, yep.
And if you think about it, they're also a good demonstration of hypocrisy. Because in other situations, secular scientists take today's measurements and extrapolate them backwards into the past. And that's called uniformitarianism. And they criticize creationists because we say that this approach isn't valid, while secular scientists insist that it is. But here, uniformitarianism disproves the secular view, so what do? They abandon it.
They abandon it, exactly. Okay, well, we got to cut out of here. You can order Spike's excellent video series, the series that the anti-creationists tried to boycott. That was when I knew Spike had hit a home run, when the response was systematically dodging Spike's points. I knew he was onto something. Spike goes into a lot more details in what he discussed here in those videos. You can also sign up for his ever-informative newsletter, all at his website, creationastronomy.com. Thanks so much for joining me here today, Spike.
Thank you, Ian. Happy to be here.